Okay, so what do you know about perimeter? What do you do to find the perimeter of a figure? You add up all the sides. So even though we got an x, we don't really care that we got an x. We're just going to add it. We're going to add up all the sides. So that would mean we're going to add in x. Let me shut the door. So, and then what I would put x plus, what do y'all think I'm going to write? 8 plus 9. Yeah. Yeah, okay. And what does it equal? All of that is the perimeter. Did they tell me what the perimeter was? It's 24. So this is a way of adding the sides together to show the perimeter. But they actually told me the perimeter was 24, so I can just make my equation by saying all those things added up equal 24. Should I maybe clean that up?
What did you put, like x plus 17 equals 24?
Yeah. Let's go ahead and, did it tell me to solve it? No, so guess what? You don't have to solve it. If you look in the book, if you were to see the answers right now, I can because they're in my book and they're in the back ears. They don't actually have you solve it, so you do not have to solve it unless you just want to. What they do is they clean the expressions up. So 8 plus 9 is 17, and that's where they stop, right there. You don't have to find it. Could you do it in your head? What do you add to 17 to get 24? You like 7, right? So you could solve it if you next. 21 has a rectangle, and they label all the sides. And the sides are either 8 or x. And they want us to write an equation, and they tell us it's a rectangle, and they tell us the area is 40. How do you find the area of a rectangle? What's the formula for it? Length times width or base times height. However you learned it, it's the same thing, isn't it? It's one dimension times another dimension. So I'll say length times width because that's what most of you said. Do I know what the area is? Do I know what I should put there? 40. They told me it was 40, right? What is the length there? 8 is considered the length. And then x is considered the width. Y'all see how that's just all they're wanting you to do there. Again, you don't have to solve it. What would the answer be, though?
40.
Well, 40 is the area. What is x? When you divide both sides by 8, it'd be 5, right? So you can see really. All right, it says 27. A bookstore has sold all but 12 dictionaries. All but 12 dictionaries. So I'm going to record things I know first. I got 24 total cars. It's either red or blue, so I need to describe red cars. I have a feeling, right, because that's what word problems ask me to do. I'm going to have to describe the different types of cars and blue cars. Don't know how yet, but I'm going to keep reading, right? There are 3 more blue cars. I love this. 3 more blue cars than twice the number of red cars. Does anybody remember what I told you last time about sometimes there's a word in the word problem that kind of gives you a clue what the variable should be? Do you remember what I said? Anybody remember that? Well, let's see. Oh, okay, they gave it to you, sorry.
Yeah.
Okay, they're telling you that the number of red cars is what our variable is going to be. There was a way I could have known that without them telling me. And here's where it is. Normally in a word problem, when you're trying to set it up, if you see that word than, not only is it a switching word, it often indicates that the thing that you want to use as your variable comes next. Because it's not that you'd have to use it that way, it's just that usually that's the easier way to set the problem up. If you look for the than, the idea that comes next is usually what's going to be the variable, and that's actually what they told you to do here, and we could have known that would have been the easiest way to do it because we see that than. It says than twice the number of red cars. Do y'all agree that twice the number of red cars all kind of goes together, that little phrase kind of goes together? Okay, so what do y'all want to call red cars? They call it by the letter R. Y'all good with that? Okay, so we're going to call red cars R. Okay, and it says what we're supposed to do is now write the equation. So we got to figure out a way to write this equation. Let's start at the beginning. I haven't described blue cars yet, but maybe I won't have to if I use the R. Let's start at the beginning. 3 more blue cars. What does that tell me I'm going to do?
Plus 3.
Add 3 to something. And because there's a than, it switches it. So I'm going to put the plus 3 here, and I'm going to put something else in front of the plus 3. Isn't that what the switching order thing about than does? These are just general guidelines. It's not like there's a hard math rule that says this is what you do. It's just that teachers have noticed over the years that this is an easy kind of way to take it apart if you're stuck figuring out what to do. Okay, so 3 more blue cars, then what? Something's going to go here. Now the than's going to tell me what's going to, then all that comes after it. Twice the number of red cars. How would I say twice the number of red cars? 2R, right? Because we said R was red car, so it would be 2R. Okay, so 3 more blue cars, then twice the number of red cars. So that describes what?
That describes blue cars.
That describes blue cars. 3 more than twice the number of red. So that's blue cars.
And then another R code.
Yeah. Do you agree with me that blue cars plus red cars is total cars?
Yeah.
Right? And there are 3 more blue cars than twice the number of red cars. All that really told me how many blue cars there was, didn't it? So let's see. Each car in a fleet of 24 rental cars is either red or blue. There are 3 more blue cars than twice the number of red cars. Actually, we've described both types now. So what am I going to do here? Do I know how am I going to describe red cars? Luke already said it.
2R.
Well, there was 2R plus 3 blue cars, right? What did we call red cars? R, just R, didn't we? We actually wrote it up there in red. Do you see it? This is how many blue, that's how many red. And what am I going to put as the total? If I add the blue and the red together, I get the total cars. Did they tell me that? 24. Now, I kind of came up with that blue cars plus red cars as total cars, because isn't that a relationship that I see in that problem? If I walked out on a rental lot and they just had blue and red cars, I count them up, there's 24. I know that I could add the blue and the red together and get the total. Okay, so this is how I would have done it. Your book gives a different answer, and it's the same thing, but I just want to show you what your book does. This would have been fine. I could have gone ahead. Let's look at this answer first. I could have combined 2R and R. Wouldn't that be 2R plus 1R makes 3R?
That's what I was thinking.
Okay. Yeah, that's just cleaning it up a little bit, right? And then you get 24. We could solve it if we wanted to. Did they tell me to solve it? Nope, so you don't have to. You can just stop there. Now, that's not what the book says, but they've got the same answer as we are. It's just in a little bit different order. When you're solving word problems, the thing that makes it kind of hard is sometimes you got choices, and the choices can sometimes confuse you because you might be thinking of both ways in your mind and not know which one to pick, and, well, what do I go with? I like this just because I know that when I see than, it makes it easier for me to kind of pick the variable, because sometimes it gets confusing, trying to, in some problems. Here's what your book did. I'll do it in black up at the top. They said the number of blue cars, they thought a different thought. They said it's equal to the total cars minus the red cars. Did any of you think that way about it? Okay. Are they right and I'm wrong? Does it matter? No. Are we going to get an equation that's going to give us the same answer either way? Yeah. So just because they said you had to do it that way doesn't mean that's the only way to do it. I like the way I did it better than I like the way they did it, but I see that what they did is equally fine, right? So what they did is they said the number of blue cars was 2R plus 3, and that's equal to the total number of cars, which is what, 24, minus the red cars, which was R. So that's what you'll see in the book. If we rearrange this and I added R to both sides, wouldn't I have the same thing that I wrote? So don't feel like you've got to have exactly the same thing as the book all the time, as long as it makes sense. Take your answer if they give something different and try to see, maybe you can move terms around and it's equal. You can tell if it's equal if you can move the terms around and get what they have on theirs, just by adding and subtracting things from both sides. And like I did here, I end up getting, if I add my R to both sides, I get 3R plus 3 is 24, which is what we got down here when I did it a different way. All right, they tell us they want the length of a side to be a variable, and even if they hadn't told me that, I probably would have had to think about that anyway. The word problems get harder in the book, and they're kind of introducing them to you here, trying to get you to think about what would you do if you got this type of word problem. What do you know about a square, about all the sides of a square?
They're the same.
They're the same. In geometry, we draw a little line like I'm doing here just to show if I put one line on each side, that means all the sides are equal. That's just something you do in geometry. So if I call this side S, I don't like using S's for variables, but that's what they use in the book. They look too much like 5s to me. But I'm going to go ahead and do it just because that's what they do. I can see how you're going to check this answer. If all those sides are the same, and they tell me the perimeter, if the perimeter is 51, how am I going to come up with that 51 given those S's? What do you do to find perimeter? 4S or 4X, right? I could say I could say S plus S plus S plus S, but I know that's the same thing as 4 times S, right? So if you need to put S plus S plus S plus S, put it. But if you are comfortable with it, it'd probably be easier to put 4S, which that looks like a 5 now, but it's not. 4S is 51. So S is the length of a side. That would be the variable they're looking for. Oh, thank you. I was thinking that was a weird number. I don't know where I got 51. It is 116. Thank you. So we need to fix that. If you've been copying from up here, it's 116. Thank you for following along and keeping me on track there. So that means this should be...
You're just doing an example.
I don't know where I got that. I probably looked at a different problem. I don't know. It looks like I pulled that out of thin air. So who knows? Who knows? So is everybody okay with that? And now if we want to know what one side is, we could just divide 116 by 4, couldn't we? And we'd know what one side is. So that's what they're asking you to do there.